Okay, welcome back to the next part of my Earth to Mars video. In the last video, I finished configuring the XR2 for the ride up to orbit and eventually out to Mars. And I went ahead and completed the ride up to orbit, so that's done. So if you're rejoining me in this part, welcome back. Let me go ahead and unpause the simulation. And we'll jump back inside. And now we'll go about doing the various things that need to be done in order to get everything going here. I always like to take a look at a few things right after getting up to orbital velocity. Time to the descending node, 1,000 seconds. Time to apoapsis, 800. And we're saying that we're going to do our burn for Mars here in 1,200 seconds. So we've got time to take care of some maintenance.
Translation, rotation.
If you remember, I brought that extra fuel module with me. So what I'm going to do is open the APU, or start the APU, extend the radiator so I don't overheat. And I want to roll upside down like the space shuttle does when it jettisons the external tank. It rolls over first. Let's go to the payload camera. And I want to jettison slot 3, make sure I've got the right one.
Payload deployed.
Deploy that.
Translation.
And we'll translate away from it a little bit. Take a look at the external view. So this part will go around and burn up in the atmosphere since we haven't circularized our orbit yet. That's just the same thing as the external tank would do on the shuttle. Once they get up to their initial orbit, they jettison the tank and then go on with the OMS 2 maneuver to circularize their orbit. Go ahead and close the doors. Done with the APU. And we'll go back to this main view. Okay. Now I always feel more comfortable in the prograde position. Alright, now let's figure out what we need to do and what order we need to do it in. Okay, I think I will go ahead and circularize my orbit because I am going to reach that. Although technically I wouldn't have to, because I will reach the ejection point here long before I'll get back, down into the lower part of the atmosphere. But nevertheless, I'll go ahead and do it anyway. And I just want to check the aligned plane MFD to see if I will have any chance to work with the relative inclination. Looks like I probably won't, because these two burns are really close to overlapping. So, at any rate, let's go ahead and warp time ahead to get to the to this point. And let me even be, I don't know if you want to call it lazy, but go ahead and use burn time calculator. Press MD to get to the time to apoapsis. And we'll press the circularization so that once we get to this point, it will fire the engines and circularize automatically for us. Go ahead and warp time ahead to that point. Okay, time to ignition in 2 minutes. Of course, we're at 10x, so it won't take long to get there. Okay, let's go back to real time. Go to prograde. Okay. Got a mostly circular orbit now. And we'll bring up the align plane MFD. 200 seconds. Yeah, I guess we got time to do a little bit of plane alignment here. So let me go to the orbit normal position. Basically, when the time to the node gets to 10 seconds, that's when I'll be able to do the plane alignment here. Okay, coming up on that point. Okay, we have a very low relative inclination. Got a circular orbit, so the next thing to do here in just 2 minutes is the TMI burn, the Trans-Martian Injection burn, I guess that's what it's called. And I can bring that up in an external MFD so we can see it a little better. And what I find works best for this burn is to keep the prograde autopilot on right up till you get to the point of to begin the burn, and then turn it off. You don't want to have the prograde autopilot left on through the course of the burn, which I think I actually did leave it on in my last Earth to Mars video, which was just a mistake. If you turn it off before getting to that point, the vessel won't continue yawing around the curvature of the planet, and that's actually what you want. You want the vessel to stay so that it is faced in the right direction. So we're going to begin this burn in just a few seconds. Okay, let me go ahead and turn the prograde off now. And I'm just keeping an eye here, begin the burn. 2 seconds, 1 second, and we're burning. And the amount of delta V that I need to burn through is right here. And this is actually the semi-major differences. If you keep the prograde autopilot on, then your semi-major difference will be significantly worse than if you shut the prograde autopilot off. So once this burn's complete, I will have to make an adjustment to the semi-major difference, but if I leave the prograde autopilot on, the adjustment that I'll have to make is going to be much larger. So we've got quite a bit to burn through here, so let me just press T one time to warp through this burn a little more quickly. Okay, we're getting close, so I'll go back to real time. And as I get close to the end of the burn, I'll start reducing the main engines. Okay, just a little bit more delta V, and we'll go with that.
Rotation, translation.
And use some translation to get the rest of it. But what I'm going to work on before I worry about this delta V is this semi-major difference. I want to get that to 0.
Rotation.
And I found with that much semi-major difference, the easiest way to get it to 0 is to rotate minus 270, or rather minus 90 degrees, which will have you facing 270. And then we'll just apply a little bit of main engine, and you can see that's bringing down both the delta V and the semi-major difference. A little more main engine. And if you actually pay attention to these lines, you'll see they're getting closer. Okay, now the semi-major difference is actually starting to go the other direction. So now I want to go prograde. I've just got a little more work here to do. Once I'm facing prograde, I want to actually then shut off the prograde autopilot and
Translation.
use a little bit of translation to finish refining that semi-major difference and delta V, by the way. So you can see I got the semi-major difference down to 0.013, and it looks like they're at 0.012 is as low as that's going to get. So now I'm just going to use a little bit of reverse translation to get the delta V at 0. Okay, there we have it. We got a relative inclination of 0.013. We've got a delta V of 0.00 and a semi-major difference that's very low. So I think we're in pretty good shape for getting out to Mars. Let's go ahead and take a look at the external view for a moment. Okay. And again, I'm going to go ahead and end this video at this point. Let me go ahead and pause the simulation, and we'll pick up in the next video right here at this very spot. Okay, welcome back to the next part of my Earth to Mars video. In the last video, I finished configuring the XR2 for the ride up to orbit and eventually out to Mars, and I went ahead, time to apoapsis 800, and we're saying that we're going to do our burn for Mars here in 1200 seconds. So we've got time to take care of some maintenance.
Translation. Rotation.
If you remember, I brought that extra. We'll go about doing the various things that need to be done in order to get everything going here. I always like to take a look at a few things right after getting up to orbital velocity. Time to the descending node, 1,000 seconds, and completed the ride up to orbit, so that's done. So if you're rejoining me in this part, welcome back. Let me go ahead and unpause the simulation, and we'll jump back inside. And now fuel module with me. So what I'm going to do is open the APU, or start the APU, extend the radiator so I don't overheat.